Welcome everybody to our discussion on index numbers. Index numbers are really simply just proportions or ratios in disguise. So don't overthink them. They're really just going to be basic fractions that are related to another fraction. So we can solve for missing pieces by doing our simple cross multiplication tricks or whatever technique you use for solving ratios, proportions. The most common index price that people know is the consumer price index called CPI. So as a, official definition, the index number provides a way of comparing measurements made at different times or in different places. What it is we take the value of one particular thing and we use that as the reference value or the base value. And then the index number for any other thing is simply how it relates to that original thing, right? So you can think about an index number as being the price of something divided by some reference price. And then they multiply by 100 to turn it into a percentage. So you can just see that, this price is 120% of the index, the chosen reference price, and so on and so forth. If you take a look at these numbers, I think it'll make a little bit more sense. You can see they put 1985 equals 100 in parentheses. That's telling you that that's the index price. That's the price that everything's going to be compared to. So if something cost, in this case gasoline, $1.20 in 1985, if we look back to 1965, it only cost 31%. And if we do 31 divided by $1.20, that's going to give us 25.8% as our answer. So that means the price in 1965 was only roughly almost 26% of what it was in 1985. And then, of course, if we go forward, we can see in 2015, the price is more than doubled, right? Double would be 240. That's a little bit more than double. And, of course, the percentage is a little bit over 200. Because to be 210% of something means you're twice as much, right? 200% is twice as much. So it's almost doubled. So that's all it is. It's a way of telling you how one price compares to some other price, across time. Okay, so let's take a look at a simple example. Suppose the cost of gasoline today is $2.70 per gallon. If we can use that 1985 reference price, right, as a reference value, we can find the price index number, not necessarily the price, but the index number for gasoline today. And the solution is that we're just going to set up that simple ratio, right? We know that the index number is always the current price divided by the index price, and then we multiply that by 100 to turn it into a percentage. So 270 divided by the 1985 price, which was $1.20. That comes out to 2.25. And then, of course, when you multiply it by 100, you get 225, which means the index number is 225%. And the reason why we make them percentages is because the average, person on the street, if you told them the price is now 225% of what it used to be, they understand that, rather than if you told them it's 2.25 times as much. I personally think they would understand both, but c'est la vie. Okay, so let's think about this. If we want to find the actual price of gas today, and then we could compare it to the 1985 price, then we could figure out what our price index is today. So if you've got nothing better to do today, you can do that. Okay, so let's compare these index numbers to be able to answer other types of questions, like if it cost $16 to fill your gas tank in 1985, how much did it cost to buy the same amount of gas in 2015? So instead of looking for price index numbers, we want to know actual prices. Well, that's fine, because we're just going to set up the same type of ratios. We're just going to have a different missing value. So the solution is we take what we know. We've got the index price for 1 year. We've got the index price for another year. We've got the cost for 1 year, and we're trying to find the cost for another year. So cost is the one thing we're looking for. Well, remember, these are always simply price over price equals index over index, right? So the price of something in what we'll call year one over the price of whatever it is in year 2 is equal to its index in year 1 divided by its index in year 2. And you don't have to think of year 1 and year 2 as always being chronological, right? Like, so the oldest year is 1. No. What you want to do is you always want to put the unknown piece in the top of the fraction. So since we don't know the price of gas in 2015, that's what we're trying to solve for, that becomes our unknown. That's our x. That goes on top. So we're going to have 2015 price over 1985 price equals 2015 consumer price index divided by 1985 consumer price index. And we set up this beautiful little easy ratio here. And to solve that, all we do is simply multiply both sides by 16 to get rid of this number, right, to isolate x. And that's why I say if we always put x on top, it makes the math easier because you literally only have to do one thing. You multiply the other fraction by the denominator of this one to get rid of it so that x is all by itself. So x is going to be 16 times, of course, 210 divided by 100 is just 2.1, which gives you 33.6, which tells us it would cost us $33.60 to fill our tank in 2015, which makes sense, right? Because the index was 210%, which means it's a little bit more than twice as much. So if it costs $16, twice 16 is $32, and it's a little bit more than 32. All right, let's look at another one. Suppose that it cost $20 to fill your tank in 2005. How much did it cost to buy the same amount of gas in 1965? Now, you'll notice in this question, we're no longer using the index value from 1985. We're comparing two completely different years, right? 1965 and 2005. But the beauty of our technique is it doesn't matter. You still just set up a simple ratio. So we're going to do the price of some year over the price of another year, right, equals the index of that year over the index of the other year, right? And so I call them year 1 and year 2 just to, simply delineate which is which. But again, they don't have to go chronological. You want to set it up so that the unknown is what goes on top. And we don't know the price of 1965. So we want to let x be the price for 1965, and thus we want to put that on the top of our fraction. So we have that x over 20, right, the price in 1965 over the $20 that it cost us to fill our tank in 2005, is the index from 1965, which is 25.8%, divided by the index for 2005 is 192.5. So let me say that again since I messed this up so poorly at the beginning. So we've got the cost of 1965 over the cost of 2005 equals the index of 1965 over the index of 2005. And just like before, all we got to do is multiply both sides by 20, right, to get rid of the fraction. So basically x equals 20 times that fraction. We do a little math, and it spits out to 2.68, which you go, holy moly, it only cost $2.68 to fill the gas back in 19... Yeah, because gas was a lot cheaper back then, right? So that's how we use it. We set up a simple ratio, and we solve. Now, as we talked about, the consumer price index is the most commonly used index, and it's not just for gas, it's for basically all sorts of things. And what they'll normally do is they'll kind of take a sample of thousands of products and then kind of work out an average, and then from that they can work out the consumer price index for stuff. And it basically just tells us how expensive it is to live in this world, right? It's how much stuff costs. So you can see that the index, there is nobody at 100, but it's pretty close to what it was in 83. So 83 is kind of like what we're comparing everything to. Let's look at an example. Suppose you need $30,000 to maintain a particular standard of living in 2000. So that just means that the things that you're buying, food, gas, auto insurance, your rent or your mortgage, right? All just basic living expenses. Cost you $30,000 a year to be able to just live. So how much would you have needed to do this in 2015 if you want the same standard of living? Meaning you're buying the same amount of food, you're buying the same amount of clothes and all that kind of stuff. Well, we can use the consumer price index for those 2 years, right? And we know that for 2015, it was 237. For 2000, it was 172.2. We get a ratio of 1.38. And so we know that 2015 is about 1.38 times as much, right? Things cost about 1.3 times as much as it did in 2000. So if you need 30,000 in the year 2000, all you have to do is multiply that number by this consumer price, ratio index of 1.38, and it gives you 41,400 is what you need. Now, yes, that seems like a completely different technique than what we've been doing, but it really isn't. It's still the ratio technique. We're just skipping some steps. So let me show you if we wanted to set it up in the ratio. Remember that this, instead of saying, oops, sorry. So as I was saying, instead of, thinking of it in terms of this, we can just set up this ratio to, what we're looking for and what we know. We don't know the price in 2015, so this is going to be X. That's what we're looking for. And then down here, 30,000. So you can see that all you're doing is you're going to multiply 30,000 times this fraction. Well, this fraction ends up equaling 1.38, and that's why you get 30,000 times 1.38, right? So we were doing the ratio. We were just kind of speeding up the process by taking that fraction, turning it into a number, and then when we multiply the bottom of the other fraction, we're just multiplying it by that number. How about adjustments for inflation? It's really the same kind of concept. So in this example, they tell us in 87, the mean salary for Major League Baseball players was $412,000. In 2015, it ballooned up to $4.25 million. We can compare this increase to the overall rate of inflation as measured by the Consumer Price Index. So the first thing we do is we compare the consumer price indices for those 2 years, going from 1987 to 2015. This is a typo for 2006, should be 2015. We can see that it went from 237, right? It went from 113 up to 237. So if we do this ratio, we can see that things in 2015 are a little bit more than twice as expensive as they were in 1987. So if the salaries, stayed the same, followed that same rate of inflation, then they only should have doubled instead of going up basically by a factor of 10. And we can compare that, right? There's our factor of 10. So we can see that even though prices doubled, salaries went up by a factor of 10. And that's another way of being able to compare these rates of inflation, right? So the CPI tells us that the rate of inflation for consumer goods, things that we buy and pay for, doubled in that time period, whereas the index for baseball salaries tells us that in that same time period, their salaries went up tenfold. So obviously they're living a lot better than they were before because they can afford a lot more stuff. All right, there's also other indexes that do the exact same thing. In addition to the consumer price index, we have the producer price index, which is the exact same thing, except instead of how much money we're paying for things, it's how much money producers are paying for things. And then there's all sorts of other indices that people create out there that they just basically do it so they can measure, how much stuff changes. And that's it.